Welcome to Learning Program 10-4B on the IBM Selectric Typewriter. A prerequisite for this program is the completion of our training program 10. 4A, you should not expect to be successful at adjusting the output section of the Selectric Typewriter without also having thoroughly covered the adjustments explained in segment 10-4A on the printing mechanism. Even more so than in previous programs, you will make extensive use of the adjustment manual, Form 24159-39, which is a copyrighted publication of IBM Corporation. It is imperative that you acquire one of these manuals and have it at hand while we show you how to use it. If you don't already own one following our recommendations in previous programs, we must insist that you acquire one for this program. A second requirement is another copyrighted IBM publication, Form number 24156-15, called Service Manual Selectric Typewriter. Our frequent turning to its drawings will prove the value of this book for review purposes. We recommend that you use its drawings often, particularly when you have to communicate with someone else over the telephone about Selectric typewriters. A most useful and extensively tested learning device is coloring the parts in these drawings in the manner we will illustrate. If you can possibly afford the time, this practice will substantially accelerate your familiarization with the machine. Make it a point to obtain the latest revisions of these publications. The careful revisions and additions, which IBM devotes to them, provide an extremely convenient and economical way of keeping up with the many improvements made on Selectric typewriters. This is one of the drawings from the service manual. Let's use it for a brief review of the rotate tape system before we start our adjustments. We know that the action of the rotate spring applies a constant pull on the rotate tape because the tape is connected to the rotate pulley. This tension on the rotate tape tries to pull in on both pulleys, the pulley on the rotate arm on the left and the pulley on the shift arm on the right. The shift arm is prevented from giving in to the tension of the rotate spring either by the action of the shift cam or by the action of the shift motion limiting screw, which stops the movement of the shift arm when the machine is typing small characters. On the left side, the rotate arm is prevented from rotating because the R5 selector latch holds down the -5 bail, and because the stop lugs above the positive selector latches prevent the upward movement of the selector latches. Whenever the -5 bail is allowed to follow the -5 cam on the cycle shaft, the motion of the -5 bail is transferred to the balance lever and the rotate bell crank, allowing the bell crank to turn clockwise. This motion is transmitted through the rotate link, the rotate arm, and the rotate tape, so that eventually it turns the type element by exactly 5 rotate increments in the clockwise or negative direction. A rotate increment is the angle which separates two adjacent characters of the same character band, or belt, on the type element. Whenever any combination of positive latches is pulled down, the left arm of the balance lever is also pulled down, causing the rotate bell crank to rotate counterclockwise. Through the rotate link, the rotate arm, and the rotate tape, this motion becomes counterclockwise rotation of the rotate pulley and the type element. By filtering out latches during the character selection process, we can obtain anywhere from 0 to +5 rotate increments using the positive portion of the rotate differential. By combining these positive rotate increments with the -5 rotate increments of the -5 rotate bail, we can also obtain from 0 to -5 rotate increments for the type element. To be successful with the tilt and rotate adjustments, the cycle clutch must be properly adjusted. Check it out at this point, and only then continue with this program. For the adjustment of the tilt and rotate tape systems, a few preliminary adjustments must be considered. The first is the position of the positive latch bail. We start by checking whether both rollers of the positive latch bail actually make physical contact with the cams when the machine is at rest. When you tap the bail slightly with your middle finger, as shown, you can readily hear whether there is any unwanted clearance between the cam follower and the cam. Whenever we reinstall the cycle shaft, this is one of the test points we should check. It is perfectly possible to inadvertently install the cycle shaft bearing plate in such a way that the positive latch bail cannot seat itself on both cams simultaneously. We do have an alternative. It is also possible to change the position of the right side of the pivot shaft, green pencil, for the positive latch bail by loosening the screws indicated by the yellow and the blue pencils. Notice also that the plate which holds the shaft can be adjusted forward and rearward, in addition to its vertical adjustment capability. Make whatever corrections you need to make on your machine. After you have completed the adjustment, half-cycle a character and test your adjustment when the cam follower rides on the high portion of the +5 cams. If your adjustment is correct only when the bail is at rest, on the low portion of the cams, and not when the bail is on the high portion of the cams, then change the position of the right side of the positive latch bail shaft until both conditions are met. Now we prepare to move the positive latch bail sideways so that all the links of the differential end up in a vertical position. Notice in this picture that the rotate differential needs some sort of adjustment, because the link which connects the balance lever to the upper, or base 5, horizontal lever of the rotate differential is definitely not in a vertical position. Before we perform any adjustment, however, we cycle the machine through a few cycles and let all parts seat themselves. Then we determine whether the situation persists. If it does, we proceed to correct it. Extending toward the rear of the connection point between the lower horizontal lever of the rotate differential, the base 3 lever, and its link to the upper lever, you will find a pin which fits into the indicated guide or bracket. This guide and the pin are best seen from underneath the machine, and you can see here that they control the left and right alignment or positioning of the different links. As you examine the guide, you find that it is mounted onto the bracket which holds the selector latch stop pads. A slot in the bracket allows you to move it sideways. The tilt differential does not have such a guide for left and right adjustments. For the tilt differential, we only have the guides which control the front-to-rear positioning of the horizontal differential levers. The rotate differential is equally equipped with these guides. Check whether the rotate differential links on your machine are positioned vertically before continuing. Again, check the position after you have cycled a few characters. Once the links are positioned vertically, we turn to the selector latches, which must be positioned vertically also. The vertical position of the selector latches is established by the guiding slots for the selector latches in the positive latch bail. Therefore, by changing the lateral position of the bail, we can adjust the vertical alignment of the selector latches. We adjust the lateral position of the positive latch bail by changing the position of the bracket indicated by the green pencil. At the point indicated by the yellow pencil, we find the guide slot which controls the lateral position of the positive latch bail. But this isn't all. The same bracket is also used as an overthrow stop for the positive latch bail. It must be positioned so that all of the selector latches hang vertically, and so that the positive latch bail is cammed down to within 1/4 of 1 millimeter from the bottom of the slot when the bail is on the highest point of the +5 cams. Check this condition on your machine and make whatever corrections are needed. One final provision for this mechanism before we can begin with tilt and rotate adjustments is lubrication. The cam follower rollers and guides, such as the one indicated by the yellow pencil, must be well greased. IBM number 23 grease is recommended here. The pivot points for the +5 latch bail take IBM number 10 oil. If you examine the right pivot point for the positive latch bail, you find a felt washer. Soak it with number 10 oil. Now we have come to the first adjustment proper in our series of tilt and rotate adjustments. All selector latches should reset at the same time, and that is the time at which the cycle clutch pawl resets or falls into the home or rest position at the end of a cycle. The easiest way to test for this condition is to take it in 2 steps. First, we check the resetting time of all positive selector latches, and then the resetting of the -5 selector latch. When we hand cycle a Z, using only the hand cycle wheel to drive the mechanism, we find that at the end of the cycle the selector latches did not quite reposition themselves under the positive latch bail. The condition is pointed out by the blue pencil. We then proceed by depressing the character Z a second time, and as we begin the new cycle, we can tell whether all of the latches reset themselves at the same time, and whether that resetting occurs at the time at which the check pawl resets. It may prove difficult to simultaneously observe the resetting of the positive selector latches and that of the check pawl. As a solution, we recommend that you hold a left-hand finger on the check pawl while your right hand is busy turning the hand cycle wheel. You will then be able to feel whether the resetting of the check pawl occurs at the same time or not. On the level 2, or new style, check pawl, you should be able to hear the resetting of the check pawl. It is just as important to have all selector latches far enough under the positive latch bail, but the details of that were taken care of when we studied the input section in our training program number 10.3. The adjustment consists of forming the stop pads for the selector latches. If the resetting of the selector latches slightly precedes the resetting of the check pawl, you can let it pass, as long as all of the selector latches reset at the same time. As you use the hammer and the punch, make sure that you go about it with moderation. The stop pads are made out of good steel stock and will not endure much forming. Be sure of what you want to achieve before you attempt to make any adjustments. When you lower the selector latch stop pads, as shown, the relatching under the bail will occur earlier. As a general rule, we may assume that this adjustment was properly set by the factory before the machine left the assembly line. However, since we can never tell who did what to a machine before we get to it, we must make it a habit to check the adjustment of the stop pads. The -5 selector latch, green pencil, should become reset exactly at the same time at which the check pawl resets. We test for this condition by hand cycling an M as before. When the cycle shaft no longer turns, the -5 selector latch is not yet reset. But when we begin to cycle an M a second time, we can easily check our adjustment. The condition is obtained by turning the screw indicated by the yellow pencil. We have already seen that with the tilt tape system, we can rotate the type element in a vertical plane, and we know how the mechanism operates. The question now is, by just how much do we want to tilt our element when we use the tilt mechanism? When we pull down both tilt latches, we want 3 tilt increments. By changing the position of the link which connects the tilt bell crank to the tilt arm, indicated by the blue wedge, we can vary the amount of tilt motion which is transmitted to the tilt ring. This tilt motion is also known as the tilt sweep. When the link is adjusted downward, so as to be placed closer to the pivot point of the tilt arm, we increase the amount of motion. And when we move the connection point upward, away from the tilt arm pivot point, we decrease the amount of output motion. Let us repeat that we must rely on your following our instructions exactly. Anything less than that is bound to result in failure when it comes to adjusting the selection mechanisms. With the typewriter at rest and the type element removed from the machine, go to your typewriter and examine the amount of play which the tilt ring has. The way we do this is to rock the tilt ring back and forth, without applying as much force as is needed to alter the position of the tilt pulley sector. This play on the tilt ring comes strictly from the connecting link, which goes between the tilt ring and the tilt pulley sector. When we bear down lightly at the rear of the tilt ring in order to remove the tilt ring play, we are actually rotating, or attempting to rotate, the tilt ring in the direction in which the tilt spring is constantly trying to turn the ring. The spring, and for that matter the tilt ring, cannot go any further, because the tilt tape does not allow the spring to rotate the ring beyond this point. When we remove the tilt ring play in the same direction as the action of the tilt spring, we say that we have removed the tilt ring play in the negative direction. Be careful with the clockwise and counterclockwise designations of rotation. You must define from which side you are observing the tilt ring before you use these terms. Negative direction here means the same direction in which the tilt spring tends to rotate. Conversely, here we are removing the tilt ring play in the positive direction. You will frequently come across these expressions and terms when you work on the IBM Selectric Typewriter, and it is important that you know their meaning and become fluent at using them. To remove the play in the negative direction means to remove the play in the same direction in which the tilt spring acts. To remove the play in the positive direction means to remove the play in the same direction in which the tilt tape acts. During a tilt operation, the motor acts on the tilt ring in the positive direction. We will now investigate whether we obtain the correct tilt motion when we use the tilt mechanism. In order to tell whether we are obtaining 3 tilt increments of rotation when both tilt selector latches are pulled down, and not 3.5 increments or 2.5 increments, we must first know and be able to remember our reference point. On your machine, you should follow exactly the 4 steps we are about to describe. First, we start by half-cycling a letter Z second, we use the right hand to disengage the tilt detent from the tilt ring. Third, with our left hand index finger, we remove the tilt ring play in the negative direction. Now, with the play removed in the negative direction, we repeatedly release the tilt detent, disengage it, and release it again, while observing exactly where the tilt detent engages. This is the V-shaped cutout on the edge of the tilt ring. It doesn't matter at this point whether the detent seats itself exactly into the V-shaped opening or not. In fact, we don't much care if it does not even engage in the V-shaped cutout. What matters is that we observe, with the best possible precision, exactly where in relation to the cutouts in the tilt ring the detent meets the skirt of the tilt ring when we have all tilt ring play removed in the negative direction, because that constitutes our reference point. Once we know where that is, we commit the point to memory. This means we must form a mental picture of where the detent touches the tilt ring at a time when all of the play is removed in the negative direction, and when the tilt detent is then allowed to engage with the tilt ring. If you want to see the point at which the detent first touches the tilt ring, you should position yourself so that you can look into the slot indicated by the red pencil and observe the movement of the detent so you can tell exactly where it engages with the first of the V-shaped cutouts in the tilt ring, indicated by the yellow pencil. However, there isn't any need to rely exclusively on the eye to tell where the tilt detent engages with the tilt ring. Many experienced servicemen accomplish the same thing by simply feeling the amount of rotation, which the detent causes on the tilt ring when they release the detent with their right hand. This drawing is also one of the drawings from the IBM Selectric service manual. The figure on the left is an illustration of the correct detent engagement when the play is removed in the negative direction. On the right, we have an illustration of how a correctly adjusted mechanism should look when the play is removed in the positive direction. Notice that the total amount of tilt ring play is approximately equivalent to 1/2 of one tilt increment. If you have much more than that, you should recheck your alignment adjustments and check the connection between the tilt ring and the tilt pulley to locate the cause of the large amount of play and then remove it. After we have checked our tilt play once, it is okay to continue the adjustments without always rechecking the detent engagement with the play removed in the positive direction. We shall simply use the detent engagement point when the play is removed in the negative direction. Therefore, fix the drawing on the left in your mind so that you know and remember how it should look. It shows the condition which should be met by an accurately adjusted tilt home position. The adjustment which brings the tilt ring into this position so that it meets these conditions is called the tilt homing adjustment. We will perform it a bit later. At this point, it does not yet matter whether the detent touches the correct point on the tilt ring. The important thing is for you to know where it encounters the tilt ring and to retain that spot in your mind. Once you have committed to memory what the engagement condition is on your typewriter, you can go on. Here we have half-cycled a letter J, as in January. J is a tilt 3 character, meaning that it requires 3 tilt increments to properly position itself for printing. We now perform exactly the same test. First, we half-cycle a J second, we disengage the detent with the right hand. Third, we remove all the tilt ring play in the negative direction with our left index finger. And fourth, we release the detent again to find where, in relation to the V-shaped cutout, the detent first touches the ring. The question then is, how does the detenting of the J compare with the previous detenting of the Z? Do the two characters detent on the same spot in relation to their respective V cutouts? If not, we need to make a tilt motion adjustment because we have obtained either more than 3 tilt increments of rotation or less than 3. On many machines, it becomes impractical to attempt to remove the tilt ring play in the positive direction when the J is half-cycled. This is because the tilt ring reaches its maximum top-to-the-front rotation before all of the play in the link between the tilt ring and the tilt pulley sector has been taken up. This is part of the reason why we recommended that you use the negative rotation of the tilt ring as a reference. We can again visually inspect the detenting of the J by looking through the indicated slot. If the J does not detent in the same way as the Z, you should either increase or decrease the motion of the tilt arm by respectively lowering or raising the link on the tilt arm. Be sure to loosen the nut indicated by the green pencil before attempting to move the position of the tilt link. The size of the bolt head can easily deceive you into believing that the bolt is much stronger than it really is, and on account of that, it is very often broken by inexperienced and experienced servicemen alike. The only thing one really has to learn about tilt and rotate adjustments is the adjustment procedure. Fortunately for us, this procedure is basically the same for most of the adjustments in the tilt and rotate systems. This is the adjustment procedure for tilt motion adjustments. First, check the home position of the tilt ring detenting and make a mental note of its position. We use the half-cycled Z for this test. Second, decide which way you have to make your correcting adjustment. You must move the link closer to the pivot point of the tilt arm when you wish to increase the amount of motion of the tilt arm. Third, loosen, adjust, and retighten the nut and the bolt which connect the tilt differential to the tilt arm. Fourth, cycle the machine through 3 or 4 characters in order to let the mechanism settle before you check your results. Fifth, check the results by first testing the home position again with a half-cycled Z, and then testing the tilt motion with a half-cycled J. We must recheck our home, or rest, position detenting in step 5, because it is very probable that our tilt motion adjustment changed the home position slightly. We simply repeat the steps of this procedure whenever we have not yet arrived at the desired amount of tilt motion. This routine is so important that you will be doing yourself a favor if you write it down once, so as to have it readily available whenever you need it, particularly during your early stages of Selectric servicing. You may consider noting down only the key words typed in red. At this point, adjust your tilt motion until you have reached equal detenting conditions for the home position detenting, or the Z, and for the J, or the tilt 3 detenting. What you are checking is whether the 2 characters detent on the same spot in relation to their respective V cutouts. If they do not, you need a tilt motion adjustment because you have obtained either more than 3 tilt increments of rotation or less than 3. Now let us assume that you adjusted your tilt motion until you obtained equal detenting conditions for Z and for J, as shown in this drawing. This, however, is not yet the condition which we should ultimately have. We still have to perform a tilt homing adjustment. You should still be able to remember how the rest position or home position of the tilt ring should look. Let us see whether you can tell in which direction you would have to turn the tilt ring in order to obtain the correct adjustment. Your answer should have been clockwise in the positive direction. The tilt ring must be rotated clockwise when seen from the left side of the machine. Notice that the detent is the fixed point in this adjustment. In this picture, is the clockwise rotation a rotation which aids the tilt spring, or which counteracts the tilt spring? Your answer should have been that clockwise rotation of the tilt ring, when seen from the left of the machine, is positive rotation. It must be motor-driven, and it has to counteract, or overcome, the force of the tilt spring. Since we already know how the tilt mechanism operates, we know that to correct this condition, we only need to pull on the tilt tape in order to rotate the tilt ring positively, against the action of the tilt spring. By first loosening the nut indicated by the yellow pencil, and by then turning the screw indicated by the green pencil, it becomes possible to change the home position of the right-hand tilt pulley. Can you tell which way we should move the pulley in order to adjust the home position of the tilt ring? When we turn the screw clockwise, we pull the pulley toward the outside of the machine. When we turn it counterclockwise, we allow the pulley to move further into the machine. While you're at it, take a look at the fine thread on the tilt homing adjustment screw. Needless to say, we must make sure that the nut on top of the tilt pulley is completely loose before we start turning the tilt homing adjustment screw, because of the tremendous mechanical advantage developed by the turning of the screw. Another important detail about this tilt homing adjustment: the tilt homing should only be checked when the nut indicated by the yellow pencil has been tightened again. The reason is that the tightening of the nut has a considerable effect upon the rest position of this right tilt tape pulley. Here's the complete sequence for the tilt homing adjustment. We recommend that you use this sequence of steps until you have learned how to perform the tilt homing adjustments. First, check the home position of the tilt ring and make a mental note of its position. Second, decide which way we have to move the right tilt pulley in order to correct the adjustment. Third, loosen the tilt pulley locking nut, then rotate the tilt homing adjustment screw by whatever amount we think the machine requires. Finally, retighten the right tilt pulley locking nut. Fourth, cycle the machine through 3 or 4 characters to allow the mechanism to settle or seat itself. Fifth, check the results by investigating the detenting of the new home position for the tilt ring. At this point, we should also check the tilt homing in the tilt 3 or J position. We repeat this routine whenever we have not yet arrived at the desired end result. Complete the tilt homing adjustments on your machine before moving on. At times, it takes making this tilt homing adjustment before one can tell that the tilt motion, or tilt sweep, is still out of adjustment. If the tilt detent engages exactly with the center of the V-shaped cutout in the tilt ring, it becomes much easier to compare the Z and the J detenting conditions. In a way, it is even practical to make it a point to adjust the tilt sweep under such conditions. There are many different ways of going about an adjustment. After you have learned one, don't hesitate to develop a new way, just as long as it works out correctly. We know that the tilt mechanism controls the vertical position of the printed characters, but we also know that the tilt detent controls the rotate detent. So if the tilt detent does not work, the rotate detent can't possibly work either. With the completion of the tilt homing adjustment, we've finished the adjustments of the tilt tape system. This can hardly be called difficult, and we ask you to simply repeat this portion of the training until you can make the adjustments without any assistance. If you have even the slightest doubt about the whole process, consider reviewing it from the beginning of the tilt adjustment sequence. Make it a point to be accurate and meticulous in these adjustments. For instance, if the mechanism is not clean, clean it first. You cannot expect to make accurate tilt homing adjustments if, instead of the tilt tape resting on the tilt pulley, it rests on dirt, such as eraser residue caught between the pulleys and the tape. Be just as neat as you can afford to be, and get your adjustments as close as you can to the conditions shown in this drawing. If you said clockwise, as seen from the left side of the machine, you nailed it. That's positive rotation. It has to be motor-driven through the tilt tape, pulling the ring against the constant force of the tilt spring. If your answer was that it counteracts the spring, well done. Positive rotation always works against the tilt spring, so to correct the home position, we simply pull on the tilt tape and overcome the spring's pull. If you reasoned it out from the screw, good work. Turning the tilt homing screw clockwise pulls the pulley toward the outside of the machine, and counterclockwise lets it move further in. Just be sure the locking nut is fully loose first, and remember the homing only counts once that nut is retightened. Our first adjustment in the sequence of rotate adjustments is the vertical position of the rotate arm. The indicated line on the rotate arm serves as a center line or guiding mark on the solid rotate arms. Older machines will simply have the tip of the rotate arm come to a sharp point in place of the center line. From now on, keep a running list of the adjustments we are about to discuss. There are only 7, and they are all very simple to make, but they must be performed correctly and in the correct sequence. So please have pencil and paper ready for this purpose. We will tell you when to take notes. In either case, the pointed tip on the old-style rotate arm, or the line on the solid rotate arms, should be lined up with the number 1 scribe line on the hooverometer. We must first cycle the machine to the point at which no mechanism or clutch is engaged. To check the vertical position of the rotate arm on solid rotate arm machines, it is best to tilt the typewriter on its back. We then touch the base of the hooverometer against the left outside of the power frame, as shown here, and use the center line of the rotate arm as you would use the sight on a rifle. Obviously, in our case, the vertical position of the rotate arm needs to be adjusted. Let us briefly review some basic mechanics. In the drawing on the left, the solid line represents the rotate arm in a non-vertical position. When we rotate the arm positively through the angle alpha 1, we describe the arc ob, of which the horizontal component is x. The angles alpha 1 and alpha 2 are of the same magnitude. When we rotate the arm negatively through the angle alpha 2, we describe the arc AC, of which the horizontal component is YC. Notice the difference in length between the two horizontal components. YC is considerably shorter than X. In the drawing on the right, the angles beta 1 and beta 2 are also of the same magnitude, but this time the rotate arm is positioned vertically. Now the horizontal components YX and YC are the same, only because the rotate arm, represented by the solid line, is in a vertical position. Since the rotate arm on the Selectric typewriter must swing positively to produce 5 positive rotate increments for the type element, and also swing negatively to produce 5 negative rotate increments, it becomes obvious why we must make sure the rotate arm is positioned vertically. The rotate arm must be vertical because we want the horizontal components of its motion, or sweeps, to be exactly equal. We have learned that the rotate differential can deliver a maximum of 5 positive rotate increments when we pull down all the positive rotate selector latches. The same amount of rotation, but in the negative direction, is obtained from the -5 rotate bail by disengaging the -5 selector latch and releasing the -5 rotate bail. We must be able to transmit this motion to the element in the same way. The positive angle of +5 increments of rotation must have the same magnitude as the negative angle, which must be an angle of -5 rotate increments. Here is another way of saying this. The horizontal component of the +5 rotation of the rotate arm must have the same magnitude as the horizontal component of the -5 rotation of the rotate arm. The turnbuckle on the rotate link is used to adjust the vertical position of the rotate arm. Notice the threads at the ends of the turnbuckle. On the right, the thread is quite coarse, while on the left, the thread is substantially finer. When the turnbuckle is turned top to the front 1 full turn, on the right it takes up 1 full turn of thread, while the thread on the left gives out 1 full turn. However, the horizontal length between the two threads is quite different. On the left, the turnbuckle gives out less horizontal distance than what it takes up on the right. The end result is a shorter rotate link. Since the rotate bell crank is fixed, by shortening the rotate link, we end up turning the rotate arm in a counterclockwise direction when observed from the front of the machine. When you loosen or tighten the nuts of the turnbuckle, be sure to always use 2 wrenches, as shown here. If you use only 1 wrench, the end result may well be a broken tip at the bottom of the rotate bell crank. The same applies, of course, to retightening the nuts of the turnbuckle. When retightening the nuts of the turnbuckle, it is important that the rotate link be free around the studs at the bottom of the rotate arm and at the bottom of the rotate bell crank. It is quite easy to build in a condition which makes the rotate link appear to be twisted. What gives this condition away is that the rotate link might have very little or no axial or angular play. To check it, we verify whether we have any play when we try to turn the turnbuckle back and forth after it has been retightened. Problems resulting from a poor rotate turnbuckle adjustment range from a bind in the rotate mechanism to early signs of wear in the link, because of poor or improper seating of the rotate link around the studs. An alternative to having to be so careful with the retightening of the turnbuckle is to leave one of the locking nuts completely out or simply tightened against the end of the thread, as shown here. Under these conditions, all you have to do is cycle the machine through 3 or 4 characters to give the rotate link a chance to seat itself. In the process, the arms of the rotate link will adjust their angle themselves, and the rotate link can now function in the same manner as so many other links and clevises in this typewriter. Whatever your choice on this matter, be sure to check the adjustment of the vertical position of the rotate arm once again, after you have tightened the turnbuckle and before you go on to the next adjustment. Your rotate arm should be aligned exactly with the number 1 scribe line on your hooverometer. The correcting or compensating adjustment for this rotate drift is also accomplished by using the turnbuckle of the rotate link. We will hear more about this later. In order to continuously make up for this wear or drift, early Selectric typewriters came equipped with wear compensator rotate arms. However, these wear compensator arms turned out to have a series of shortcomings, which prompted IBM to recommend that they be crippled and thus transformed into the equivalent of a solid rotate arm. All new machines come equipped with a solid rotate arm. This rotate arm crippling routine requires 4 steps. First, break off the indicated lug. Second, lift up the nylon where compensator roller, yellow in this picture, all the way to the top of the slot in the rotate arm. Third, change the position of the rotate arm spring as shown in this drawing. Fourth, and finally, replace the screw, shown in green, which holds the rotate arm pulley, with the new style screw which does not have the eccentric stud. Instead of replacing the stud, it is also possible and acceptable to rotate the eccentric stud so that it occupies its maximum leftward position. We should then check the operation of the rotate arm by rotating a letter M and observing whether the rotate arm is allowed to rotate all the way inward on the power frame. At no point should there be any interference coming from the stud, such as it touching the power frame. You may even encounter machines with the stud simply filed or ground off. Since we have just completed our first rotate adjustment, let us prepare a list of the 7 sequence steps needed for the adjustment of the rotate mechanism. Let us reference and remember this first adjustment by the number 1 scribe line on the hooverometer. When we studied the shift mechanism, or rather the shift clutch, in program 10.1a, covering the positive power on the Selectric typewriter, we found that, except for its labeling, the machine doesn't truly have a shift mechanism in the traditional meaning of the word shift. As with every adjustment, there is a fixed point used as a reference point and a movable or adjustable point for the shift arm motion adjustment. The fixed point for the shift arm motion adjustment is the high point of the shift cam. Whenever the shift arm roller is on the high lobe of the shift cam, the position of the whole shift arm is established by that high lobe on the cam. And except for the possible influence of the shift cam backup roller found on older machines, this position is fixed or non-adjustable. As a result, with the exception of the last 2 adjustments of this sequence, from now on we will perform all rotate mechanism adjustments with the shift arm on the high lobe of the cam. We simply use the shift lock mechanism so as to print capitals only while we perform the rotate adjustments. With this explanation out of the way, we can perform the preliminary homing of the type element, meaning that we adjust the position of the type element so that when we cycle a capital Z, home position, we do in fact obtain a capital Z on your machine, depress the shift lock key, and then hand cycle the operational shaft until the shift arm is held out as shown. Now position the carrier above the cycle shaft so that you can reach the set screw which locks the rotate pulley to the rotate shaft. On wide machines, with 13-inch or 15-inch platens, you can also move the carrier all the way to the left against the left side frame and then reach the set screw. The preliminary homing of the element is accomplished by a process referred to as slipping the head or slipping the element. It is probably the easiest procedure of the whole sequence. Find the exact size of Bristol wrench or spline wrench for the indicated set screw, which holds the rotate shaft to the rotate pulley. Only if your typewriter is also locked into capitals will you be able to reach the set screw approaching it from the left side of the machine, as shown. So let this fact serve you as a clue as to whether or not your shift mechanism is locked into capitals prior to making this type head homing adjustment. It is absolutely mandatory that the adjustment be performed with the machine ready to print capital letters. First, loosen the set screw and then turn the element somewhat so as to be sure that the rotate shaft and the rotate pulley are not stuck together in some way. On your machine, we should not have any problems since the pulley was taken out a bit earlier. Later, during the retightening of the rotate pulley, we must be aware that the rotate shaft should have some very small amount of end play. 1/10 of 1 millimeter is sufficient. We need just enough play so that we can be sure that no binds were created as a result of our type head homing adjustment. Now retighten the set screw slightly so that you can still slip or turn the type element only. You should now be able to tell clearly, by feeling the resistance, whether you are simply turning the element within the head play of the dog bone and its sockets, or whether you are actually slipping the rotate shaft in the hub of the rotate pulley. After having installed the type element, half-cycle a capital T, a degree mark, or a capital J, which are all 0 rotate characters. And then, with the right hand, disengage the rotate detent in the same manner as we did when we checked the adjustment of the tilt homing and the tilt motion, or tilt sweep. With the left hand, you can now rotate the element into the position you want and need, namely the position in which the character you chose on the keyboard actually appears in the correct position for printing. We mentioned earlier that exactness is important, and there is no doubting that this is so. But notice that this adjustment was called preliminary homing of the type element. This means that later on we will be making other adjustments, which may have some effect on this preliminary type head homing adjustment. However, we ask you now to adjust this preliminary homing exactly as if it already were the final or fine homing of the type element. This picture shows you this ideal condition. Notice the manufacturing seam line on the element, indicated by the green pencil. When you remove all of the play of the type element in the negative direction, the clockwise direction when viewed from above, and then allow the rotate detent to come into engagement with the teeth at the skirt of the type element, you should find that the detent moves along a vertical imaginary line, which is the exact continuation of the indicated manufacturing seam line. Some people object to the use of this manufacturing seam line for this alignment because of the difficulty of seeing the line or a variety of other reasons. They propose that one should say, when looking at the rear of the machine, that the detent should come in contact with the edge of the tooth at the point located 1/3 of the way up the negative slope of the tooth, starting from the bottom of the V-shaped cutout in the skirt of the element and going to the tip of the tooth. Have it your way. But remember, you must have your typewriter locked into capital characters, and only when you attempt to print capital Z, capital T, or capital J will you get the seam line. For a small Z, T, or J, there is no seam line with which to align the rotate detent. If you are able to see the seam line, make it easy on yourself and use it. The procedure will keep you from making inadvertent mistakes. Now go back to the set screw in the rotate pulley and tighten it down. Be moderate about it so as not to over-torque it. This enables us to add one more step to our list of adjustments pertaining to the rotate tape system. For memorization purposes, let us remind ourselves of the preliminary homing step by the all-important fact that it must be performed when the shift mechanism is locked so as to select capital characters. If we manually disengage the rotate detent, then remove the type element play in the positive direction, and then let the detent return to the skirt of the element, we find that the detent comes in contact with the element at a point located 2/3 down the positive slope of the V-shaped cutout in the element, as shown here. Thus, we find that the total play between the slots in the dog bone and the pins on the ball sockets amounts to 1/2 of the distance between two teeth of the type element. On a new machine, this play may be quite a bit smaller, but when on used machines it is noticeably larger, the dog bone should be replaced. Let us now go to the next rotate adjustment. It starts out by our having to keep in mind what the detenting position of a home character, such as Z, T, or J, is. Therefore, you must be able to remember the exact detenting condition of a home character. The balance lever has its fulcrum at the point indicated by the green pencil. The positive arm of the balance lever, indicated by the blue pencil, is of a fixed length, connected directly to the pin indicated by the green pencil. However, the length of the negative arm of the balance lever, indicated by the yellow pencil, is changeable. In our third adjustment in the sequence of rotate adjustments, we will have to adjust the -5 arm of the balance lever so that both arms become of equal length. The balance arm must produce the exact same amount of rotation for the rotate bell crank when the right side operates as when all of the selector latches on the left side of the balance arm operate. Notice that the -5 arm is held in position by a bolt at the green pencil and a nut indicated by the yellow pencil. While you adjust the -5 arm of the balance lever, if you don't use 2 wrenches before you attempt to turn the bolt, you will cause the bolt to turn with the nut. Please use 2 wrenches when you adjust the balance arm. The letter B is a +5 character. This means that all of the rotate selector latches will be operating, and that the left side of the balance lever will be rotated downward by a total motion, which yields +5 rotate increments. Let us barely start to hand cycle the B, and then disengage the -5 selector latch by pushing the latch toward the front of the machine with a screwdriver, so as to allow the -5 bail, at the green pencil, to come up in the same cycle in which all of the latches of the positive differential are pulled down. Thus, we obtain a cancelled B cycle. If the balance lever has been adjusted correctly, and we then cycle a cancelled B, there should be absolutely no rotation of the rotate bell crank. This means that no rotation of the type element should result from a cancelled B operation. Once the nut and the bolt which hold the -5 arm of the balance lever have been loosened, we can increase or decrease the length of this arm. To give us a reference point, IBM has conveniently provided the indicated notches on top of the balance lever. The center portion is fixed, but the two outside plates are part of the -5 arm and are movable left and right. First, however, we must be able to decide which way we should adjust our balance lever. Let us walk you through an example. This is what we found on our typewriter when we performed the cancelled B test. The rotate detent engages with the skirt of the element as shown here when we check the mechanism with the head play removed in the negative or clockwise direction. Remember that without the cancelled B routine, the seam line of the type element aligned exactly with the vertical path of the rotate detent. In this case, the type element evidently turned in the negative direction when it should have stayed exactly where it was earlier, with the seam line aligned with the detent. Since only the -5 arm of the balance lever is adjustable, all we really need to learn is how to ask ourselves the correct question. Here it is. Do we get too little negative rotation from the balance arm, or too much negative rotation from the -5 arm of the balance lever? Can you supply the answer? Your answer should have been too much negative rotation. Always ask yourself, do I have too much or not enough negative rotation? Whenever the element does not rotate at all during a cancelled B cycle, the adjustment of the balance arm is correct, of course. Since we detected some negative rotation of the element, we realized that too much of the input motion coming from the -5 rotate bail was transferred to the rotate bell crank. We can reduce the output motion of the -5 rotate arm by lengthening it. In this case, after loosening the nut and the bolt on the balance lever, we use a small screwdriver inserted between the tail of the fixed positive arm and the -5 link on the negative arm of the balance lever. By swinging or inclining the screwdriver toward our left, we apply the leverage needed to increase the length of the negative arm of the balance lever. The longer the lever of the input motion, the smaller the output motion sensed by the rotate bell crank. If we had found insufficient negative rotation of the element during the cancelled B test, we would have had to move the -5 arm of the balance lever toward the left. In that case, we would again use the small screwdriver as a lever, only this time placing it between the rotate bell crank and the -5 link, applying leverage that tends to shorten the -5 rotate arm of the balance lever. The shorter the distance between the input -5 link and the point where the balance lever connects to the rotate bell crank, the greater the amount of motion transferred to the bell crank. Just remember the question, do we get insufficient negative rotation or too much negative rotation from the -5 arm of the balance lever? Then perform your adjustments accordingly. Before we can check the result of our adjustment, as with all the tilt and rotate adjustments, it is most important that after adjusting the balance lever, we run 3 or 4 character printing cycles to allow the mechanisms to settle. Furthermore, the balance lever adjustment often affects the position of the type element. So before we perform the cancelled B routine again, we must determine exactly what the new home position of the element is before we can investigate whether the balance lever needs further adjusting. In this case, our home position is evidently still okay. But don't count on that always being true. If it changed on you, remember the new position and go on to the next step. Now we half-cycle another cancelled B, and then check our results. Since the position of the element did not change compared to the home position, we conclude that the balance lever is now truly balanced. This is the routine for the balance lever adjustment. Be sure to know it by heart. 1. Check the home position of the element and make a mental note of it. 2. Perform the cancelled B test and decide which way to move the -5 arm of the balance lever toward the left when you need to increase the output motion, the negative motion of the element, and toward the right when you wish to decrease the output motion, the negative or clockwise rotation of the element. 3. Loosen, adjust, and retighten the negative arm of the balance lever. 4. Cycle the machine through 3 or 4 characters to allow the mechanism to seat itself. 5. Check the results by first investigating the new home position of the element and then carrying out the cancelled B test. Notice that the basic procedure is almost always the same. Check, decide, loosen, adjust, retighten, cycle, check results. As a final comment on the balance lever adjustment, many servicemen object to having to reach into the -5 selector latch and disengage it to check the machine for this adjustment. They prefer to use the letter O instead. O is a -1 character. We saw that a -1 character is obtained by selecting -5 rotate increments and +4 rotate increments simultaneously. +4 rotate increments is only 1 rotate increment short of +5, and it is possible to check the balance lever adjustment using it instead of B, simply because the approximation is close enough. However, when you use O, you no longer have the benefit of the seam line to guide the adjustment. But with O, you do not have to reach into the machine to release the -5 latch. Feel free to select whichever procedure you prefer. This lets us make one more entry in our list of rotate adjustments, the adjustment of the balance lever. Let us key it with the letter B, since it starts with B as in balance, and since we use the cancelled letter B to check the adjustment. With the balance lever adjustment, we have completed the adjustments pertaining to the rotate differential. Next, we turn our attention to an adjustment that transmits the differential output motion to the type element. If you said too much negative rotation, exactly right. The element drifted clockwise when it should have stayed put on the seam line. That means we lengthen the -5 arm of the balance lever to reduce the output motion reaching the rotate bell crank. Once the rotate differential delivers its adjusted input motion to the rotate bell crank and the rotate link, it is up to the rotate arm to transmit it further through the rotate tape. At the bottom of the rotate arm, yellow pencil, we find that the screw holding the rotate link to the rotate arm fits into a slot, making it possible to vary the output motion which, through the pulley red pencil, is transmitted to the rotate tape. If we raise the link, we bring the point of application of the input motion closer to the fulcrum point of the rotate arm, with the end effect of increasing the output motion, or the rotate arm sweep, without affecting the input motion. Conversely, if we lower the connection point between the rotate link and the rotate arm, yellow pencil, we move the point of application of the input motion farther from the fulcrum point of the rotate arm, and thus decrease the output motion, or sweep, of the rotate arm. What we need is 5 positive rotate increments when we call for them, and 5 negative rotate increments when we want them. Here too, always make sure you cycle a few characters before checking an adjustment you have just made. Again, we have an adjustment routine. First, we establish our reference point by investigating the exact position at which the rotate detent engages the skirt of the element when the machine selects a 0 rotate character, such as the T, the Z, the J, or the degree symbol. Be sure to note that we must remove the head play, or dog bone play, in the negative or clockwise direction when viewed from above the machine. You must remember that this is the new home position of the element, since you will be asked to compare it to the detenting condition resulting from the next adjustment check. Now that we have made a mental note of the detent's engagement point with the element in the home position, we half cycle a B, but do not cancel it. We are about to check the sweep of the rotate arm. We then check the new detent engagement point and decide whether we are turning the element by the correct angle. With a B, we must ask whether we are turning the element too far in the positive direction or not quite far enough in the positive direction. The detent engagement for the B should be the same as the engagement point we noted when we half-cycled a 0 rotate character. In this example, we obviously rotated the element a bit too far in the positive, or counterclockwise, direction. The type element overshot the point at which the detent should engage a cutout in the skirt of the element. We came too close to the vertex of the V-shaped cutout. Too much sweep requires that we move the connection point between the rotate link and the rotate arm farther from the pivot point of the rotate arm, so that we reduce the sweep, the output motion, of the rotate arm. First, however, let us perform the same rotate arm sweep test by half-cycling the letter M. The M is a -5 rotate character. With it, we can also test the sweep, or motion, of the rotate arm. When we half-cycle an M, the rotate detent should engage the skirt in exactly the same way as when we half-cycle a 0 rotate character, such as the T or the J. If it does not, all we have to ask is, did the element rotate enough or too far? Keep in mind that this time the rotate mechanism rotated the element negatively or clockwise when viewed from above. In this example, we merely confirm our earlier observations. We have too much clockwise rotation this time. The rotate arm swept too far into the machine, too far in the negative direction. We conclude that we have too much rotate arm motion with the M check, and we also had too much rotate arm motion with the B check. Make it a point to review these last two examples very carefully. Notice that for the B check, the detent touched the negative slope of the tooth too close to the tip of the tooth. In both cases, we had too much motion, too much sweep, just like a windshield wiper that hits the frame of the windshield on both sides. The exact inverse happens when we do not have enough motion in the rotate arm. Be sure to analyze what the symptoms should be for the case of insufficient rotate arm motion, because when you are confronted with this problem in the field later on, you will not be able to figure it out unless you do your homework now. Pause here if you need time. At this point, let us insert another most important comment. There are quite a number of parts in the rotate tape system, and the loss of motion detected in one machine or mechanism may be quite different from the loss of motion detected in another. For example, there are occasions when the B check yields too much rotate arm motion, while the M check does not yield enough. When all of the selector latches do not reset under their bales at the same time, this is exactly what may happen. If you encounter this variation in sweep, compare the resetting time of the R5 selector latch with the resetting time of the positive selector latches, and make the appropriate corrections, even at the expense of noncompliance with the manufacturer's specification in the adjustment manual. Remember, however, that afterwards you must again go through the whole sequence of adjustments that comes after the adjustment of selector latch resetting. This is just one of the reasons it is so important to have a sequenced list of adjustment steps while working on the IBM Selectric Typewriter. Let us return to our problem of excess rotate arm motion. Whenever the element is rotated too much or too far, the sweep of the rotate arm must be decreased by lowering the connection point between the rotate link and the rotate arm. Green pencil. Notice the slot for the screw that holds the rotate link to the rotate arm. By lowering the link, our input motion is placed farther from the fulcrum point of the rotate arm, yellow pencil, and thus the output motion, or sweep, is reduced. After you have changed the position of the rotate link, don't forget to cycle a few characters before you check the adjustment again with the B and the M. As with the previous adjustments, you might have to change this one quite a few times before you get the desired results. Using your previous notes as a guide, you should now write down the steps to follow in performing the rotate arm sweep adjustment. We will not spell them out on screen this time. Pause the video to allow yourself time for this assignment. The sequence of steps is still the same. First, check the home position of the element and make a mental note of the detenting conditions. Second, perform the rotate arm sweep test using B or M and decide whether you need to decrease or increase the rotate arm output motion. Third, loosen, adjust, and retighten the connection between the rotate link and the rotate arm. Fourth, check the results by first finding out whether there was any change in the home position, and then performing the rotate arm sweep test again using the B and the M. Your sequence was probably better, clearer, or simply easier for you to understand. Let us remind ourselves of this adjustment by the fact that it controls the sweep of the rotate arm, and key the entry with the letter S. You should make your own notes, expanding on these whenever there is the smallest possibility of misunderstanding what we are writing down. Now we make the last adjustment in the sequence of adjustments that must be performed with the machine locked in capital characters. It is the final homing, or fine homing, adjustment of the element. As we explained earlier, The various adjustments of the rotate tape mechanism are likely to have introduced small changes to the home position of the type element. Now we return to this adjustment and make sure the detent zeroes in on the seam line when the type headplay is removed in the negative or clockwise direction. Since this adjustment is only a refinement of the homing position of the element, IBM recommends that we use the turnbuckle of the rotate link to perform it, even to the detriment of the number 1 scribe line adjustment. You will soon find that certain base plates will not let you reach the rotate link as easily as you can reach the rotate pulley under the rocker. Considering how easy it is to slip the rotate shaft in the pulley, and in this way adjust the exact home position of the element, we suggest that you do not hesitate to use the element or head slipping method to adjust the fine homing of the type element. Again, we make an entry in our list of adjustments for the rotate mechanism. The purpose of this list is to remind us not to lose track of the sequence of these adjustments. It is important that we never make any of these adjustments out of sequence. We must make them accurately, well, and in sequence. If you think you must go back to some earlier adjustment for one reason or another, start at that point and then continue the sequence from there. Now we turn our attention to the detenting of small characters. First, we release the shift mechanism to return to small characters. Then, we half-cycle a small t, and it should detent exactly the same way as the capital T. We can regulate the amount of motion delivered by the shift arm through the indicated screw in the right side of the power frame. It is an extremely easy adjustment to make. Some older machines might have this adjustment of the shift arm motion, or small letter detenting, directly on the shift arm. Do whatever applies to your machine to make the small t detent exactly the same way the capital T detents. Here again, you will have to get by without the seam line, because the small t does not have the seam line lined up with the detent. In our sequential list of rotate adjustments, let us identify this adjustment by the reminder: small characters as shown. Finally, we come to the last adjustment in the sequence. Actually, it is not just a rotate adjustment, because it consists of the timing between the printing mechanism and the selection mechanism. The rotate detent is controlled by the print shaft, and the rotation of the element is driven by the cycle shaft. We perform the adjustment by loosening the print shaft gear and then turning the shaft as needed. When we cycle a capital M and also a small m, the tooth of the element should rub against the rotate detent at the time of the withdrawal of the detent. But we do not want any snapping action when the detent finally comes out of engagement with the tooth. On pre-dual impression machines, we allow a greater margin, as you can see in the drawing on the left. The constant action of the rotate spring tends to turn the element clockwise and away from the rubbing tooth condition. By adjusting the withdrawal time as we did, we leave the withdrawal to the very last possible instant in the operation. Of course, this also establishes the latest possible detent engagement time. This way, we build in maximum detenting reliability. Timing is our last entry in the sequence of rotate adjustments. As mentioned many times, all of the described adjustments must be carried out in this sequence. It is therefore necessary to memorize it so that we can recall it when we work in some office offering beautiful distractions. The red letters in each of the adjustments can represent each adjustment and help us remember the sequence. Let us form a sentence in which each word begins with one of these letters. Here it is. The first letter actually stands for number 1, but take a Roman one and you've got it made. Pause here and do whatever it takes to memorize this sequence. As the rotate mechanism sustains wear, the type element will automatically rotate clockwise, giving in to the action of the rotate spring. Given enough wear, the detent might come into engagement at a time when the element has not yet been rotated far enough. The typewriter would then print the wrong character. We should allow for maximum wear potential, which is the amount of wear the system can tolerate without making a wrong character selection. Our adjustments were made to allow for the equivalent of about 1/2 of one rotate increment of wear before the machine makes a wrong selection. Any variation in detenting will cut down on the wear potential, and it should be avoided at all cost. Use the letters W, O, R, M, T to obtain a good cross-section of the overall detenting conditions. The greatest possible variation between the detenting of two character positions is called bandwidth, and it must be kept to a minimum. Now test the machine thoroughly, and then critically reinspect both the written material and the rotate adjustments before boxing up the machine. It is our sincere wish that you soon experience firsthand how rewarding it is to master the Selectric typewriter. Thank you.